second derivation, which deals with division, differentiation of quotient of two functions. When you have functions that are in quotient form, division form, then they appear to be depending on the same independent variable like x. How do we differentiate this function? We use the rule called the quotient rule. Let us establish that rule for us before we apply it. So let's assume that we have let y equals to u over v, right? And your u depends on x. Likewise, your v depends on x. Using the same approach we use in establishing the product rule. Y plus change in y is equals to u plus change in u all over v plus change in v. Then my change in y standing alone, y plus change in u all over v plus change in v minus my y being carried to the other side, that is u over v. The SCM is v into bracket v plus change in v. So this is v into bracket u plus change in u. Then minus my v cancel them, that's u into bracket v plus change in v. Then this change in y. So change in y will be, you can expand out, this is uv plus v change in u minus uv minus u change in v. Everything is divided by v squared plus v change in v. So that's what we have here. Then we can say this one is change in y over change in x. You divide each of the entity that needs to be divided by x. That is the entity that depends on x, divided by x. Then this is uv can cancel themselves. Then we have v change in u all over change in s. Yes, because we have function v and change in v depending on x, so you can divide it by x. Minus u change in v can also be is dependent on x, right? All over v squared plus v change in v. V change in v. Of course, v change in v also depends on x. V is a function that depends on x. This one also depends on x. Of course, this one can be dependent on x. V change in v. V is a function that depends on x, and change in v also depends on x. Of course, we know that change in y goes to 0 to have a total derivative. Change in x goes to 0. Change in v also goes to 0. If change in y goes to 0, then we have the y, the x. V change, this one is going to v, the u, the x. U depends on x, that's going to be the total derivative minus u, the v, the x, all over v squared. Because this v, change in v, change in s, change in v will, which is depending on change in s, will be 0, and that gives us only v squared here. So this gives us what we call the quotient rule, which is the y is equal to v du ds minus u dv ds all over v squared. This is the second rule that we are going to use in solving our problem. Let's get on.